Okay, guys, now we're going to look at the conditional and biconditional truth tables, and this is section 3.4. We're going to make the basic truth tables, and then, of course, we're going to use those, all right? You got to know these basic truth tables at the very end of this lecture, or this part. I'm going to put them all up at the top so you have them to look at, so when you're solving actual bigger problems, you can use them. But essentially, let's look at this conditional, which is the if-then statement. It's the arrow symbol that we've been using. That's called a conditional statement. We had the conjunction, the disjunction, which is and or. Then we've got the biconditional, which is the if-then, and the biconditional, which is if and only if. Okay. So let's take a look at this first one. You passed the final. This first case right here in red. Both you passed the final and you passed the course are true statements. Okay? So does that mean that if you pass the final, then you pass the course is a true statement? Well, we know that you do pass the final and you do pass the course are both true statements. So basically, if I say if you pass, so if the professor said in the syllabus, if you pass the final, then you pass the course, then it looks like the professor did what he or she promised, because you did in fact pass the course and you did pass the final. So the conditional statement that if you pass the final, then you pass the course is a true statement because both of these statements are true. So this would be true. Now, if in the syllabus it says, so this is, you got to remember the syllabus actually says, let's just say what, we're trying to determine whether the end statement is true. If the professor says this, if you pass the final, then you pass the course. I'm having trouble writing here. Okay, so that, guys, is this statement right here. If you pass the final, then you pass the course, right? P implies Q, or if P, then Q, right? Well, I'm going to shut off my notifications here. This is starting to annoy me. If you pass the final, then you pass the course. So we need to find out this P and this Q is what actually happens in the real world. So here's what actually happened in the real world. This is what the syllabus said, that if you pass the final, then you pass the course. Then something actually happened in the real world, which I've underlined here in red. Okay? And let's see if the original statement is true. Well, it turns out that I passed the final, but I didn't pass the course because I got a false on the passing the course. So did what the professor tell me come true? No, it did not, because he told me at the beginning that if I passed the final, then I passed the course. But what happened is I passed the final and I didn't pass the course. So that means his statement was a lie to me. He lied to me, so I'm going to do a grade appeal. See how this is kind of working? So now let's take a look here. Let's say I didn't pass the final, but I did pass the course. Okay, guys, so I didn't pass the final, but I did pass the course. Does that make his syllabus false? Because he said if you pass the final, then you pass the course. Doesn't say anything about what happens if I don't pass the final, does it? Doesn't say a word. It just tells me what happens if I do pass the final. So this statement is still true because this situation has not proven his original statement false. Okay? So let's say I passed, in this last case, now going back to red, I didn't pass the final and I didn't pass the course. Okay? Well, again, he just told me that if I passed the final, then I passed the course. He didn't tell me what was going to happen if I didn't pass the final. He didn't guarantee that I'd pass or fail the course. So this statement could still be true because it does not prove the overall statement wrong. So this is the basic truth table. This is the hardest one to understand, guys, this one. That if I have an if-then statement and the first half of it is false and the second half of that statement is true, the overall statement could still be true. Okay, let me think of another example here. So if I say, if I give you an if-then statement, if it's Friday, then I will give you $100. So let's say it's not Friday and I give you $100. Let's say I give you $100 Thursday. Is my original statement a lie? Or could it be true? Well, the answer is it still could be true because I didn't tell you anything about what was going to happen on Thursday. I said, if it's Friday, I give you $100. So if I give you $100 on Thursday, it could also be true that on Friday I'll also give you $100. So just because it's not Friday and I give you $100 doesn't mean that the overall original statement is a lie. It's like if I say to my daughter, if you get an A on your test, then I will give you $1,000. But then she doesn't get an A on her test, and I still give her $100. She's like, well, you lied to me. I said, no, I didn't. I said, if you get an A on your test, then you'll get $1,000. But I never said that meant that if you didn't get an A, you still wouldn't get $1,000. So if-thens are kind of weird because you can still be telling the truth when the P is false. So this is conditional statements. Again, you're going to have to know that truth table. The only time that a conditional statement is false is when the first one is true, meaning I satisfied the P, I passed the final, but then the instructor didn't allow me to pass the course because he told me at the beginning that if I passed the final, then I passed the course. So if this is true, if I do this and then I fail the course, I'd be pissed at my professor and I'd do a grade dispute with him or her. Okay, so that's the conditional statement. Okay, now let's look at the biconditional statement. Okay, biconditional is the if and only if statement, the double arrow that we used previously. So now we're going to look at, let's say in the syllabus I told you guys that this statement right here, you pass the course if and only if you pass the final. Okay, you pass the course if and only if you pass the final. So, what would that one mean? Well, that if let's say what happens in reality is I pass the course and I pass the final. Then you would say, oh, the professor told me the truth. I passed the course and I passed the final. So that means that if I pass the course if and only if I pass the final. That's true because I passed both, which means it should be true. So a double true means true. Now, I passed the course if and only I passed the final. Let's say the syllabus says that. But let's say I passed the course, that's the true, but I didn't pass the final. Well, then that means the professor lied to me because he says you pass the course if and only if you pass the final. That means that if I pass the course, I pass the final. If I pass the final, I pass the course. So I can't pass one and not the other. That's what if and only if means. So this one is false. Again, here's a false and a true. That'd be a false because I can't pass the course and not pass the final. I can't not pass the course because I'm false in passing the course and pass the final. I've either passed both of them or neither of them. And then false, false. You pass the course if and only you pass the final. Well, let's say I didn't pass the course and I didn't pass the final. Well, that makes sense because if I didn't pass the course and then I can't pass the final. And if I didn't pass the final, I can't pass the course. So this would be true. I know that's a lot of stuff being said there. So this is my general truth table for the biconditional statement. Okay, here's a summary of everything we've done. We've got, first of all, the negation. The negation of statement has the opposite meaning as well as the opposite truth value. So if P is true, then not P would be false. If Q is false, then not Q would be true. Then we have the conjunction, which is the or. The only case in which a conjunction is true is when both component statements are true. So an and is only true when both are true. Otherwise, it's false. Disjunction is or. The only case in which a disjunction is false is when both statements are false. So remember, with an or, if one or the other is true or both, then the overall statement is true. If then, the only case in which a conditional is false is when the first component is true, first component statement, the antecedent, we call that, is true, and the second component statement, the consequent, is false. So if I have P implies Q, the only time that this overall statement is false is when this is true and that's false. Okay, then that would make this overall statement false. Every other time, it still could be true by the examples I gave about the test and whatnot. The biconditional is true only when the component statements have the same truth value. So if I have a P implies Q, if and only if, if this one's true and that one's true, okay, then this would be true. Hang on. Then that'd be true. Or if this is false and this is false, then that'd be true, as long as they have the same truth value. All the other cases, the other two cases, would be false. The overall statement would be false. Okay, so here's all the 4 truth tables that we've constructed. There's the and, the or, the conditional, and the biconditional truth tables. And for 2 variables, or 2 statements, P and Q. We're going to do one with P, Q, and R, but we're going to get to that. That's going to take a little bit here. So we're going to first start off with some basic ones that are not super easy, but we will start with an example where we do P implies Q and not P. All right, so again, we do our basic PQ truth table, which we start off all of these with the same thing. They could both be true. This is true, that's false, this is false, this is true. And then the last case is they're both false. So now we'll build this, okay? So the first thing we're going to find is we're going to start in the parentheses, and we're going to find P imply if P then Q, the conditional. We also need to do a not P column because we have a not P. And then we do our final answer, which is we do the first thing with an and then the not P. So first thing is we're doing P implies Q. We're using these 2 columns right here. P implies Q, and so true, true. If we go up and we're using this conditional truth table. True, true translates as true. True, false is the only false example that we talked about. False, true is true, and false, false is true. I just got these from right there, okay? Now, not P means we just negate the P's. So this is going to be P is true, not P would be false. False, true, true. So I just negated all 4 of those to the opposite truth value. Now I'm going to be comparing this and this with an and between them. With the and between them. So I am using which truth table? I'm using this one right here. So remember with and that both statements would have to be true. So since in the first comparison with the blues, this one and this one, true and false, that would be false because they're not both true. False and false, that would be false. True and true is the only one that's true. True and true is true. So that's my truth table. So this is my final answer. And the whole truth table is your actual answer. So you're always going to start with, again, this block pattern right here with all these with 2 letters. This block pattern. Okay, now we're going to do a little bit longer one where we slowly break this one down. Okay, so we first notice that there is a not P, so we're going to need a not P at somewhere in this point here. We have a not P in the problem. Now we're going to start by looking at the things inside first, okay? These 2. So we're going to construct the first one, which would be a not P if and only if Q. It's a biconditional. Then the next one would be the not P implies Q, or if not P, then Q. And the last one is going to be the whole kit and caboodle. That's going to be the not P if and only if Q. And I'm wrapping here a little bit. That's all right. Not P implies Q. So we're just slowly work our way up. So not P just means change the truth values of the P. So this would be false, false, true, and true. Now for the not P if and only if Q, I'm dealing with these two, right? Not P if and only if Q. Well, that means for the if and only if table, take a look. We're looking at this one right here. It's only going to be true when they're both true or they're both false. Okay? So that would be here would be true, and here would be true because they're both true. So the other two will be false because one true and one false. Okay? Now I'm going to do not P implies Q. So this is not a biconditional, this is a conditional. So now I'm going to be working with this truth table up here. And the only time that statement is false is when I have a true then a false. So true then false only happens right there, right? Where not P is true and then the false comes after it. Remember, we're kind of going backwards in the table because the not P appears first and the Q appears second. So we got to go backwards. So true then false is the only time we have a false statement. Okay, so this is a false statement. True then true is true. False then false is true. And false then true is one of the true ones if you look over here. Okay, so now I'm taking this one, I'm comparing these two columns with the very last one, and I'm using a conditional, which means I'm using the blue underlined. I'm using this one again. This one again. Okay? So the only one that's going to be false is the one that starts with true and ends with false, but none of them do, right? False true is this case right here, and it's true. So my first one is true. And it turns out if you run down the line, this is true. This is true. True implies true is true. False implies false is false. True. So all four of those are true. All four of those are true. So this is my truth table for this one. These get kind of hard. There's a lot of details, a lot of nots and ands. I wish I could make this a little bit easier. It's pretty tough to. It just takes experience. So let's erase some of this. Okay, two facts I want to point out, two terms I guess we'll call them. When we do our truth tables, we call a statement a tautology if it is true for all possible cases. The last problem we did, if you notice, it got a true all the way down, which means that it is a tautology. If we do our truth table of a particular compound statement and we get all falses at the last column, then that means it's a self-contradiction. So in the homework, you're going to have a section where they have you construct a truth table and they ask you to determine if it is a tautology. So I'm going to erase a little bit here. The way you tell a tautology is if you make your truth table like we have been doing. So if you build your truth table here, and you got a bunch of columns and and you get to your final step and it's all truths, that's a tautology. Has to be all truths when you get to your final step. Okay? Now I'm making that same table if I did the whole thing. And I got all falses at the end. That would be a self-contradiction. Okay? So basically these two sections are all about building truth tables and using these 4 tables to slowly build. And remember, we always started, okay, with our, in most cases, P and Q. We sometimes had an R in there for one problem. And then we kind of slowly build pieces all the way up until we get to our final big compound statement that we're trying to find the end result for. Okay, that is it for today. Hope we may have some questions on Wednesday on this stuff. That's okay.